So it's weird. You got to like go outside and wash your hands and, you know, global pandemic and all. All right. So here's what we got. Don't get your name wrong. Don't get your class period wrong. Right. Don't screw those up. All right. Sodium alginate. Has anyone ever actually heard of sodium alginate before? Okay. Somebody last period was like, yeah, it's like it's like an ingredient for like weird things. So I got some sodium alginate from the internet. Modernist Pantry. There's like a whole like movement of like food, like chefs that like make like flavored foams and gels and like spherical. I've never had it. It's really cool science, and I've definitely like read books and like tried a couple things and stuff. But that sodium alginate is, you might also see sodium alginate in ingredients as carrageenan or carrageenan, sodium alginate, carrageenan, and it comes from giant brown kelp. So if you've ever picked up kelp, the fresher the better, off the beach, and it's got like that slimy outside stuff, that's the sodium alginate. So one of the periods today, I licked my finger. No, I got my finger wet and I put it in there and I put it on my tongue. And it's like, well, it's like yesterday when I went to the dentist and I got the fluoride on my teeth. And it's just kind of like gummy and sticky. You know what I'm talking about? And it's just sticky. Yeah, true? I did go to the dentist yesterday. Oh my geez. Who's your dentist? Oh, all right. I met my dentist for the first time because our other dentist retired. Anywho, her kids went through Carmel High. Good times. So sodium alginate comes from giant brown kelp. They harvest kelp, some sort of chemical process, and they get it out. And I'm going to show you what it looks like here in a second. I thought I did that. Thank you. So this is what sodium alginate looks like, and I made it too big so I can't see both of them. Control minus. There we go. All right, so the sodium part, hopefully you can see the sodium part is the sodium ions. And I said ions because if you look closely, it says Na+. Those are sodium ions that are ionically bonded to the COO. Let's use a different color here. The alginate has these little negatively charged bits on there. Okay? But the sodium alginate is this entire molecule. So this arrow means it goes on and on and on, and there's lots and lots of them. Or this little bracket with an N, like N is just a number of these repeating over and over and over and over again. You get lots and lots and lots of them. What does this remind you of? See this right here? This should remind you of something. All right, hey, time out from your ion stuff. Drew Brielle, you'll have time. What does this remind you of right here? Should remind you of something. What's that? Sugar. Hopefully this looks like glucose. It is very, very similar to glucose except for this bit sticking off the end. And then it's got chains of things that are similar to glucose. So it's a sugar, chains of sugar. Okay? But the chains of sugar themselves don't make gummy worms. They make more of like a syrup. Okay, and I'll show you that syrup here in a second. And I'm going to draw them. I'm going to draw the sodium alginate like this because I'm not lazy, I'm efficient. So this green thing is going to represent those right there. Okay, and then I'm not going to draw the CO. I'm just going to put minus signs on it. Okay, to represent these things. It's a model. You've got a good one on your page. All right, so let's see. And did we, the carbons and oxygens and hydrogens are bonded to each other with ionic bonds. So in here, anytime you see something like where things come together but don't have a letter, it's a carbon. How do carbons and hydrogens and oxygens, what kind of bonds do they form? They're non-metals. They form covalent bonds. So do they form ionic bonds? Nay, they do not. But does the alginate form a covalent bond with the sodium? That's the ionic bond. So it's weird because it's a really it's a gigantic molecule that's got little ions sticking off of it, it's weird. Let's go with that. The sodium and alginate are bonded to, nope. The sodium and alginate mixed with ionic bonds break, but not the covalent bonds. Let's mix this with water. So I need, that's the spirit. How much was this? Does that have a size on it? All right, I'm gonna go with my sodium alginate and I'm gonna put it in my jar. I knew I had a jar somewhere. Okay, this is where it gets funky because then I'm running around and the Zoomers are like, what's he doing? Why does he keep disappearing off the screen? So, quarter teaspoon sodium alginate, and just a dab will do ya. And then I wanted half a cup of water in there, and this is a 2-cup thing. So this is about how much I've been using. Oh, all right. Wait, what are you doing? Oh, got you. Okay, so here, let's do this. I'm gonna go over here. I'm not zooming in on you guys, although it looks like it. All right, so let's do stop share and pin and there. Keep going. There we go. And autofocus. All right, so if you look at this, this is gross looking. It's like snotty looking sodium alginate. So here's how I get sodium alginate to dissolve into solution. But that's kind of boring. So, well, actually, let's look at that first. That should look kind of like syrupy. Ooh, there's a big chunk in there still. All right, that looks better. All right, so it's kind of syrupy, like it sticks to the edge, but we also want it to be fun tasting. So I'm gonna put in some, you guys see that? Where'd that go? I'm gonna put in some mayo. This one's black cherry, heavy squirt of black cherry, and a heavy squirt of acai berry storm. If you're allergic to caffeine, only ones I had were caffeinated. Actually, I had a non-caffeinated one, but it's citrus green tea, so it's probably not very tasty. All right, so we need to have those blended in there. So this is going to be our sodium alginate solution. All right, this is what we're going to try and, it's clearly not gummy worms, right? That's not gummy worms. All right, and, ooh, making a mess. All right, so we have our sodium alginate solution, and then we're gonna do let's do some more stuff. Let's go back to the plan here and see what we're doing. Sorry, folks on the Zoom. I'm trying to get things lined up. All right, we're back here. We're sharing the screen. All right, so when okay, as Paul Abdul has made it clear to us, opposites attract. The alginate molecules are really big anions. They're negatively charged ions. They repel each other. So if I'll have a whole bunch of these in my pink solution over there, and they're all pushing against each other. They're stuck to the water, which is different, but they're repelling each other. How do we get them to stick to each other? Yeah? An offsetting amount of cations. That could be a thing. Am I being vague enough? I'm trying to not give anything away. So you and your buddy come up with an answer. Don't put this. All right, so sodium chloride. Hey, does sodium chloride dissolve in water? Does table salt dissolve in water? It does. So what I'm going to do is I'm going to take some table salt. I'm going to take about, it says 3/4 of a teaspoon. And for some reason, I got the giant rock salt because that's what MB had next door. Oh, you see, like, I could have got that right there, that pink bag. That is salt. Is that 20 pounds? 25 pounds. I got 25 pounds of salt over there, but the crystals are no, it's not open yet. That's what it was. I didn't want to open it yet. So I'm going to take this salt, crystals, NaCl, sodium chloride, and I'm going to dissolve it in about 2 cups of water. And that's going to be my sodium chloride solution. And the way I'm going to dissolve it in water, how can I make it dissolve? Does anyone know how to make salt dissolve faster? Spin it. What kind of water could I use? Hot water. I could have smaller chunks of salt. So what I'm going to do is I'm just going to do the blendy thing again. Sorry, Zoomers, you can't see me blend things. So I'm increasing the surface area, so there's more sodium chloride ions exposed to the water. And I'm moving the water around, so the water's running into the sodium chloride. That ought to do. Okay. Do me a favor and rinse that off, please. Thanks. All right, that's my sodium chloride solution. I'm going to take one of these. Okay. So this is my sodium chloride solution. It's got water, sodium ions, and chlorine ions. All right, so where are we at here? Sodium chloride dissolves in water. True or false? True story. Sodium makes a cation with a what charge? Plus. It's in group 1. All the way on the far left. It is a +1 charge. So I'm going to make that blue. And I'm going to say that's what a sodium ion looks like. I'm going to make a few of those so that I can move them around the screen. Cool. All right. Let's see. So each carboxylate, so the little COO in our alginate makes an ion with what charge is that? Anybody see what charge that is? Everybody? That's a -1. Okay, so that is a -1. Look at that. I put the -1s up there already. Right, so that's the 1 minus. That's a 1 minus. Right? Sticking off of our alginate are little -1 anions. What happens when the sodium alginate solution is mixed with a sodium chloride solution? Don't answer because I haven't done it yet. Okay, don't do it. Don't do it. I know you want to. Hold on. Let's see. Let's zoom in, and then I'll put it up front so everybody can see. Sodium chloride. I want that up. Okay, there we go. All right. So folks out there, watch, and you're going to see this over here. All right. Is that zoomed in enough? That's an awkward amount of zoom right there. Okay, so here's what I got. I had a little, there it is. I'm going to eat these later, so I'm going to wash my hands. Sorry. My wife hates when I shake my hands to dry them because then I get like drops on the mirror and the window behind the sink. I hate using towels, and definitely paper towels. Hate paper towels. So that's just me. Sorry. Okay, what was I going to do? I was going to take this guy. All right, so I got my sodium alginate solution. This stuff is clearly not a gummy worm. I got sodium chloride. I forgot my worm catcher. Putting that in there. And, okay, watch right above the A in sodium right there. Can you see the tip of that thing there? Right, watching? You see the worm? Did you see the worm form right there? I did it a little fast. You see the worm come out? You guys see a worm coming out? Yeah. Making a worm there. Let's make one more worm. Let's make one more worm. And wait a second. Hold on. Wait, what's going on? You guys, wait, do you guys see worms there? Hold on. Wait, what? Where'd that go? Okay, let's look at those worms right there. Look at those worms. Are there any worms there? There's no worms there. Sodium chloride will not make a worm. Somebody earlier in the day was like, are we supposed to pretend that you made worms? And I said, no, we are not supposed to pretend that I made worms. It didn't work because it's not supposed to. You already picked that it did. Okay, it doesn't work. Shall we explain why it doesn't work? Hopefully not. That one looked, that looked really, really non-wormy compared to like the other ones. So hopefully we're making worms. I don't know. So here's what happened is what we're trying to do is we're trying to stick multiple, which way do I want to go? We're trying to stick multiple strings together of sodium alginate. We're trying to stick these things together. That's what makes a gummy worm. If I take sodium ions will stick to, one will stick to that one, and one will stick to this one, and one will stick to this one. But did I make the green thing stick together? No, I didn't. Clearly, I did not. They just kind of dissolved into pink goo out there. Not even goo. There was like goo in other classes. Like I said, I'm a little nervous. Okay, so what do you think happened? You can check with your buddy. So let's get rid of our sodium. Sodium didn't work. Go away, sodium. You should say that in your diet as well. Go away, sodium. Not too much anyway. Processed foods, high in sodium. All right, so let's try calcium. Calcium makes an ion with a, what charge? Anybody, everybody? +2 charge. Calcium is in group 2. It has 2 valence electrons. It's a metal. In order to be stable, it's going to lose 2 valence electrons and become a calcium 2+ ion. All right. How many negative charges are needed to balance / neutralize the charge on the calcium cation? 2, right? If you're +2, like if we made, calcium chloride, this salt right here, I'm way zoomed in. Sorry, calcium chloride, salt, that I have in my hand here, that tastes really bad because I tasted it earlier today and I'm not going to do it again. Chlorine, chlorine is -1. And this will make a compound called CaCl2. Does it say it on there? No, it doesn't. Okay, but I got this at the brew store from Dwayne at the brew shop. Calcium chloride, I don't know why they have it. I don't know how I knew it was there. Weird. I don't know. I found it a while ago. It's at the brew shop. You can get calcium chloride. But the reason we want that is we're going to use the calcium ions. And so, all right, she keeps telling me I have low battery. Each carboxylate on the alginate makes an ion with a blank charge. What happens? So I got to get some calcium chloride going here. So I'm going to do this thing again. Get some leftover sodium chloride. All right, we don't want sodium chloride, we want calcium chloride, so I need, yes, sir. Go for it.
Since this is +2 ionic charge, there's going to be enough to link the 2 time. So with the +2 now, they can bond with 2 of the lines.
Can bond with 2 of the lines because it's +2 in each. What's the charge on each of those like strings? -1. Each carbox. What is it? A carboxyl. Let's see. I want to go. Okay, I'm doing my calcium carbonate. Sorry, calcium chloride. Calcium carbonate would be marble, and that would be weird. So for those out there in the Zoom world, I just put my calcium chloride in there, and I need to get it to dissolve because it's in these big like spherical crystals, which are funky. And here we go. All right, no more calcium chloride in there. That's really annoying, isn't it? All right, so here, you know what? Let me just model something really quick. That's why my meter sticks are out here, because I was modeling. Yeah. Let me try this. Okay, where's my camera? You guys see me out there? So these sticks are going to represent my alginates, okay? They're big. They have a whole bunch of negative charge, so they repel each other. They don't stick them together. We want them to stick together because then we'll have a gummy worm. If we can get these things to stick together. So the problem with sodium ions, it says sodium chloride on there, is they will stick, but they just like stick one at a time like this, and then there's no reason for the sticks to stick together because they're stuck to sodiums. So what'd you say about calcium chloride? This is +2, so it'll stick to a -1 and a -1, and then now those are stuck together. It's an interesting hypothesis. Hypothesis. Okay. I made calcium chloride, didn't I? And then I put it over there. Under where? All right, let's zoom back in. Let's try this again with calcium chloride. And I'm not going to say I'm not nervous, because that would be a lie. Okay, calcium chloride there. Not you, that one. Okay. All right, folks out there, you can see the calcium chloride. Sodium chloride, yuck. And big money, no whammies. Sodium alginate. Can you see? You see it there? Oh. Oh, is that working? Oh, that looks very wormy. That looks wormy, you guys. I'm feeling pretty good about this. All right, now here's the important question. Who in here would eat a sodium alginate bonded, or no, calcium alginate? It's calcium, it's not sodium alginate, it's calcium. I got 2 takers, 3 takers. Okay, all right, hold on. So here's how this works. Oh, you're gonna use this. Yeah. You've been in the room where it happens. Okay, you're going to wash your hands with the soap and water at your tables. I'm gonna wash my hands. Then you're gonna meet me over here. I'm going to put a worm in your hands as you walk by. And I have more, if anyone.
Are they really salty?
Are they what?
Salty?
Well, we're gonna find out. We're gonna find out. So here's what I'm gonna do. I'm going to actually, thank you for reminding me. I'm gonna rinse off any of the, I want that cold. I'm gonna rinse off some of the extra calcium carbonate. Sorry, calcium chloride. because I don't know if I told you calcium chloride tastes nasty. It's sort of worm-like. Well, that looks like a pink piece of snot, actually. Oh, yeah. I got it on the floor. Okay, so did we make a gummy worm?
Yes.
Is it what you thought? Is that what you were trying to explain to us,
Yeah.
Mr. Chaucer? That was what you were trying to explain to us. So that was correct. What happens is we're going to. Oh, let's see. Those are going to have to yell at me because my headphones just died. Select a speaker. Okay, so what happened was, our calcium ions come in, they stick to one of them, and then they stick to another one, and that is neutral. And so they come in here and they stick to one, and then they stick to another one. And so what happens is all of those cross-link, and instead of having a liquid, that liquid becomes a gel, and then you drop the gel on the floor, and it's gross.